Okay, let's do some scientific notation. So I have these two numbers in scientific notation, and let's convert them to standard form. Since this exponent is negative, I need to move the decimal to the left because that's indicating the number is less than 1. And I need to move it 3 places to the left. So I'm going to have 7, 3, and that's 1, and that's 2, and that's 3 decimal places. So 1 to here, to 2 to 3, and I need a leading 0, and my new number is 0.00173, and that's if your exponent is negative. If your exponent is positive, in this case, we're going to move the exponent to the right, and I need to move it to the right 3 places. So I start with 9, and I'm going to put it behind the 0 and the 3, so I've moved it 1, 2, and then that would be my third, and that would be my fourth. So I've moved it 1, 2, 3, 4 places. And so my new number is 90,300. And so when the exponent is positive, and you're in scientific notation form and you're moving to standard form, if it's positive, you go to the right. If it's negative, you go to the left. Now, if I were in scientific notation mode, and I'm in standard form and I want to go to scientific notation, this number is less than 1, and so I need to move this decimal place here until it's directly behind the 2, and I need to move it 1, 2, 3, 4 places. So it's going to be 2.03 times 10, and I moved it in this direction, so it's negative, and it should be negative 1, 2, 3, 4, negative 4. If I have this case where the number is bigger than 1, I need to move my decimal place in this direction, and that's going to be a positive exponent. So I need to move it till it gets to right here, and that's going to give me 3.09 times 10 to the 1, 2, 3, 4, 5. And that gets me my answer. So when I move from here to the right, my exponent is positive. When I move from here to the left, my exponent's negative. Okay, last thing to do is do addition, subtraction, multiplication, or math with my scientific notation. When I add or subtract, I need to have the most positive of these two exponents. So negative 4 is more positive than negative 5. So I'm going to move this one over 1 place to make it negative 4. And so it's going to be 0.13 times 10 to the negative 4. And I'm adding. And so when I add those numbers, I get 4.25 times 10 to the negative 4th. I had 2 decimal places here, and I had 2 decimal places here, so I have 2 decimal places in my answer. Even though this only had 2 numbers, I can report to this position because I know numbers in both of those positions, in both numbers. So my final answer is 4.25 times 10 to the 4th. When I subtract, I do the same thing. I need both of these in the same exponent. So this has to go up to negative 4. And so I'm going to have minus 0.13 times 10 to the negative 4th. In this case, I'm going to use my calculator because I don't like having to do subtraction in my head. I can make a mistake. So I'm going to put in 4.12. I'm going to put in second, and then above the common sign there's an EE. You can't see it very well here, but that's where it is. And it puts just one E on the screen. And I need to put in the negative sign, so I'm going to use a minus down here, 4. And then I'm going to subtract from that 1.3 second EE, and I'm just going to put in this number here, negative 5, equals, and I get 3.99 times 10 to the negative 4th. Now, I know both positions, so I can report this entire answer. Even though this only had 2 significant digits, my final answer has 3. So now how about multiplying and dividing with scientific notation? This time I simply use my calculator, but I need to know how many significant digits here, and this one has 3 significant figures, and this one has 3 significant figures, so my answer can only have 3 significant figures. So I'm going to put in 3.54 second EE, and that's a negative 7 times 2.78 second EE negative 3. And I get 9.8412 times 10. You notice I did not write EE, negative 10. But I can only have 3 significant digits in my answer, so I'm going to keep through the 4. And the 1 tells me I just round off, so my final answer is 9.84 times 10 to the negative 10. Okay, how about this one? So I have 3 significant digits in each, so it's going to be 3.43 second EE 3 times 7.17 second EE negative 4 divided by 7.33 second EE negative 14. And I get 3.355 times 10 to the 13th. And again, 3 significant digits, so I'm going to keep through this first 5, and this 5 is telling me I'm going to round up, so I get 3.36 times 10 to the positive 13th. You don't need the positive, but there's your final answer. Let me know if you have any questions. If you do, I would be happy to answer either in class or via email if I need to. Thanks.